We're going to be continuing with geometric series, and this is page 29 of the booklet. All right. So exercise 4.3, the first question says, the 7th term of a geometric series is 1,728. 12th term of the series is that from the 10th term. Okay, so we need to revise our formula for geometric series. The term formula for that is AR to the power n minus 1. Now, the 7th term will be T7, and that is equal to AR to the power of 6, since it's 7 minus 1 on top as a power, and that would equal to 1,728. Now, T12 would equal to AR to the power of 11, so 1 less power, okay? And that's equal to 227 to the power, not to power, and 5 nines. Whoops. So, by doing this, we can now generate two equations in which we can solve simultaneously. So we're going to do equation 2 divided by equation 1, since the power of r is higher than the other one. And we'll get AR to the power 11 over AR to the power 6 equals to 227 and 5 ninths over 1728. So by doing that, let me just double check what we get. We get 32 over 243 on the right side, whereas on the left side we will get r to the power 5. Now if I do the fifth root of both sides, then I get the answer 2/3. Okay, and once we get that, we have to find our a value, the first value. So we sub this into equation 1. Okay, meaning that we'll get a times 2/3 to the power 6 equals 1728. And so we can divide that 2/3 to the power 6 over. So 1728 divided by 2/3. Let me just do that quickly. To the power 6. And that should give you a being 19683. So the term formula is now 19683 times 2/3 to the power of n minus 1. All right. So now that we do that, we need to find out the 10th term. So T10 would equal to 19683 times 2/3 to the power of 10 minus 1, which is power of 9. So 19683 times 2/3 to the power of 9 will give us 512. So our 10th term is 512. Right. So that's your homework there, which you can do later. Now we're going to do summing a geometric progression. So we learned how to find out a term. Now we have to sum up more than one term. So given that Sn, like before, is the sum of n terms here, right? Term 1 is A, term 2 is AR, and term 3 is AR squared, and so forth. Because these are all generated from Tn being AR to the power of n minus 1, where n equals to 1, 2, 3, 4. Okay? So how are we going to generate our formulas by doing this? We're going to multiply every term by r. So we need to get r times this, and all of this times r. That will get us AR plus AR squared plus AR cubed plus everything all the way up to AR to the power of n. Okay, so if we multiply this by r, then the negative one disappears. Okay, so now what do we do? We're going to do Rsn, which is this expression, equation 2, minus equation 1, which is Sn, which is this. So if you think about it, all of these terms here are going to be subtracted by all these terms here. So AR is going to disappear, AR squared is going to disappear, AR cubed is going to disappear, okay, all the way up to AR to the power of n minus 1, which is one less than this, I should say. So there's one more term before this, which is AR to the power of n minus 1, okay? And so all these terms here, if I just cross them out one by one, are going to disappear, whereas A will be left, and this will be left as well. But remember, it's equation 2 minus equation 1, so you'll have AR, whoops, wrong pen. It will be AR to the power of n minus A. And now, out of the left side of this equation, we can factorize our Sn. So it's Sn bracket R minus 1, okay, equals to A bracket something. So we can factorize this. Now, that will be R to the power of n minus 1. And if we divide R minus 1 over, we get R to the power of n minus 1 over R minus 1. There we go. Now, if we multiply this expression by negative 1 over negative 1, so all of this by negative 1 over negative 1, we will get the opposite way of running it. So instead of R to the power of n minus 1, we get 1 minus R to the power of n over 1 minus R. Okay? Oh, you know what? I forgot. There's supposed to be a in the bracket there. Sorry about that, guys. Put an A in the bracket there. Okay, there we go. All right. So now that we have this formula, okay, these two formulas, I should say, you can use them any way you want to. So I've written them down here. Now, this is used much easier if the ratio is more than 1. The only purpose is that on the bottom, if you have a ratio that's more than 1, then this will be positive. Okay, where if the ratio is less than 1, then this will be positive on the bottom. Okay, so you can use, it doesn't really matter, honestly. Even if your ratio is less than 1, you can still use this one if you want to remember one equation rather than 2. Okay, so I'm just going to stick with the second one, actually. Oh, I know. I'll just use the first one. My bad. I'm trying to remember which one I use. So, Sn, in this case for example 1, will be S10. So if we use the first equation here, A is going to be 12, bracket. Now the ratio would be 6 over 12, which is half. So write 0.5 to the power of 10, which is the letter n, minus 1 over 0.5 minus 1. Okay? Now, I know that I said to use this one if the ratio is less than 1, but I didn't, but it doesn't matter. Okay? So once I put this on my calculator, you should get that answer there, which is 3069 over 128. Now, example 2. Find the sum to 8 terms of 1, 4, 16, and 64. So A in this case is 1. Your ratio is 4 over 1, which is 4. So S of A is going to be 1, which is A, bracket. Let me just write the formula down for you. So the ratio is going to be 4 to the power of 8 minus 1 over R, which is 4 minus 1 once again. Okay, and that should give us 21845. That's a sum of 8 terms. Okay, exercise 4.4. Let's do the same thing again. Let's find the sum to 20 terms of the series. So finding S20, where that is our formula, okay, for Sn. So S20 will equal to 1 bracket 2, because the ratio is 2, okay, to the power of n, which is 20, minus 1, over the ratio, which is 2, minus 1. And that will give us an answer of 1048575. Okay? Question 2. Find the sum of the first 8 terms of the geometric series with the first term 7 to 9 and common ratio 2/3. So again, let's use this formula. So in this case, we're finding S8. That is equal to A, which is 729, the ratio being 2/3, so I'm going to write that in brackets and get ready to raise all of that to the power of 8 minus 1 over the ratio, which is 2/3, minus 1. Okay, now putting that on our calculators does give you that answer on the bracket, which is 6,305 over 3. Question 3. Find the sum of 6 to the power negative k from k equals to 1 to 10. So if we replace k by 1, we get 6 to the power of negative 1, plus now substitute in 2, and that's 6 to the power of negative 2, all the way to 6 to the power of negative 10, and that will be 1/6 plus 1 over 6 squared plus all the way up to 1 over 6 to the power of 10. So you can see that the ratio is 1/6, and A is also 1/6. So, because we're finding the sum of every value of these, from k equals 1 to 10, we have 10 terms. And using our formula, which I'll just bring down here again, right here, okay, well, that will give us, let me just double check, A, which is 1/6, so we'll do 1/6 times the brackets with the ratio of 1/6 to the power of 10 minus 1 over 1/6 minus 1. All right, let me just double check that. Just going to put on my calculator. So 1/6 times that. Okay, I get 0.199 so on, and so that would round to S10 being approximately 0.20 if I was to correct this to two decimal places. Okay. Question 4a. Find expression for the sum to n terms of the series 2, 6, 18, 54, and so forth. So, Sn, okay, would equal to that formula right there. Okay, I'll just write that once. Then we're finding Sn because we don't know how many terms there are. A is 2. The ratio in this case is 3. Now, the power of n will stay there. We don't know what it is. Right, minus 1 over the ratio, which is 3, still, minus 1. And you know that 3 minus 1 is 2. So 2 divided by this result of 2 cancel out. So therefore, Sn is simply 3 to the power of n minus 1. Now, hence, find the number of terms in the series if the sum is that. So, if the sum of the series is that, so we're just going to substitute it in. So we'll say Sn is now 129, 140, 162. That's equal to 3 to the power of n minus 1. Adding 1 to the other side gives us this. Now if I log both sides, so log of 129, 140, 162 equals to log to the power of 3 to the power of n. Okay, you know that I can move that n down anyway, whoops, like that, and then divide both sides by log 3, right? So n would equal to log of all that on the left side over log of 3. So by doing that on my calculator, I do get exactly 17. So there are 17 terms in this series that add together to give you this number. Moving on. Exercise 4.5. For the series 256 plus 384 plus 576, find the 11th term. Okay, so we want to find that 11th term, meaning that we need our term formula. So Tn is equal to AR to the power of n minus 1. Maybe I should write that there. then I need to find out T11. Okay, so A is 256, but the ratio here will be 384 over 256. Now, 384 divided by 256 can simplify to give you 1.5. So we're going to write 256 as A times the ratio of 1.5, but to the power of n minus 1, meaning if I substitute in 11, then I'll get 11 minus 1, which is 10. So 256 times 1.5 to the power of 10 will give me an answer of 14,762.25. Okay? Alright, now we're going to find the sum of the first 11 terms. So, S11. Before we do that, actually, we need the formula. So, Sn is A r to the power of n minus 1 over r minus 1. Now, to find A, we're going to just put in that value, 256. R would be equal to 1.5 to the power of n. So n in this case is going to be 11 terms, minus 1, over r, which is the ratio, once again, which is 1.5, minus 1. And by putting that on my calculator, I do get S11 equal to 43,774.75. Okay. Question 2. The sum to n terms of a geometric series is given by Sn being 3 to the power of n plus 1 minus 3. So that's the sum formula for n terms. Okay. We need to find the first term. The first term is given by the sum of one term. So if we now put in n as 1, then we get 3 to the power of 1 plus 1 minus a whole number 3. So that is equal to 3 squared minus 3. 3 squared minus 3 is the number 6. So the first term is 6. The sum of the first 12 terms. Well, that means we have to find S12, which is equal to 3 to the power of 12 plus 1 minus 3. So that's going to be 3 to the power of 13 minus 3. And that does give you the answer in the bracket, which is 1,904,320. And then finally, the 12th term. That means we have to find out T12. Okay. Now T12, how would you find that if you don't have the term formula and the ratio? To do that, it's easy. It's using the formula Sn, which is the sum to n terms, minus S of n minus 1, so the sum of one less term, equals to Tn. Okay? Or I should have written that way around. Okay? So Tn equals to the sum of n terms minus the sum of n minus 1 terms. So in this case, T12, or the 12th term, is the sum of the first 12 terms minus the sum of one less term than 12, which is the sum of 11 terms. Sum of 12 terms is already found in the previous question, so I'm just going to substitute that in. Whereas I'm going to substitute in 11 into this, which means we get 3 to the power of 12 minus 3. And by doing this, our answer for the 12th term should give us 1,062,882. Moving on, question 3. Now, for this particular question, I do believe the answer was wrong. Let me just double check. Okay. All right, let's move on. So, for this particular question, you've got a numerator here, which is a GP, because each time you have a number multiplying by 2 Oh, actually, no. It is going up by 2. It's not a GP, it's an AP. So this question was in the wrong place, sorry, but we can do this as revision anyway, right? So remember how Sn is equal to n over 2, 2a plus n minus 1d. Okay? We're going to apply that to both the top and bottom. Right. So S of n, oh, actually, you know what? This is a tricky one because each term, okay, is representing a sum. So this term here, the third term, is actually the sum of 3 terms in this series and the sum of 3 terms of this series. Now that becomes a term. So how we write this is we're not writing Sn, we're writing Tn is equal to n over 2, then 2a, which is 2 times 2 in this case, okay, where this is a, plus n minus 1d, which is 2. So it's going up by 2. You can evenly see that. Now this is all over, once again, n over 2. There's going to be the same number of terms on the top and the bottom. And then 2a, a in this case is number 1, plus n minus 1d, like that. And you can see that the n over 2's can cancel, and we can simplify whatever's inside here. So let's do this straight away. We'll have 4 plus 2n minus 2 over 2 plus 2n minus 2. And these 2's cancel, whereas on the top you will have 2n plus 2 over 2n, which is m plus 1 over n. Okay? I'm just double checking that. Yep, and that's right.